Hello, my Algebra 1 students. Here's what we are going to be doing today. We're in Unit 2, and this is Lesson 2.3, which is solving multi-step equations. And so we're going to be taking a look at these objectives, which are I can use inverse operations to solve multi-step equations, as well as I can use the distributing property to solve multi-step equations. So let's go ahead and start looking at some things. Well, how can you solve multi-step equations? Multi-step equations are going to mean that there is more than one operation happening to the variable in my problem. So for instance, I could have an example of like 2x plus 5 equals, I don't know, 15. There is multiple operations happening to this x. Okay, there's an addition of 5 as well as a multiplication of 2. So that's something sometimes we call them two-step equations, multi-step. Sometimes there's even more than 2 steps. And so we're going to take a look at some of these problems as we go through. I believe there are 4 examples here. Sorry about not having that on the first slide. So again, just solving multi-step equations. To solve multi-step equations, use inverse operations to isolate the variable. So again, we want to get that, if I had this same equation, I want to get this x by itself so that I eventually just have x equals something, okay? So we're going to use inverse operations or the opposite operations to find that solution. So let's go ahead and look at a word problem to start us off, okay? So example 1 says the height in feet of a tree after x years is 1.5x plus 15. After how many years is the tree 24 feet tall? So ultimately we want to know what our problem is, and we're going to underline it. So it says after how many years is the tree 24 feet tall? Now, knowing our operation is going to involve solving for that variable. And so we're going to need to know this actual equation, so I'm going to circle that, as well as I'm going to circle how tall it would be at the end. That's going to be important. Some other bits of information that's going to be important, the fact that it is in feet, and then x shows how many years. So we want to know how many years that's going to take. That means we're going to solve for x. So what I'm going to do is I'm going to take this problem, so 15x plus 15, and we're going to set it equal to 24 because we want to know how many years is it going to take till it's this tall. And then we're just going to solve for x, okay? So again, I want to think about the operations that are happening to x. In this case, I've got an addition as well as a multiplication. Now, for the most part, and there are instances where this doesn't work, but for the most part, we want to get rid of that addition or subtraction first. So the inverse of adding is subtracting. So on each side of my equation, I'm going to subtract 15. I like to draw a line down my middle of my equation so that I remember that there is a left side and a right side to my equation. A positive 15 and a negative 15 cancel each other out. So I have 1.5x equals, and then I got to take 24 minus 15, which is 9. And then I need to undo this multiplication of 1.5. So on each side, I'm going to divide by 1.5 and divide by 1.5. I'm pretty sure this last unit I was telling you not to use a calculator. For this one, I'm completely fine if you want a calculator. So if I plug this in the calculator, that gives me an answer of 6. So x equals 6. And to finally answer my question, after how many years is the tree 24 feet tall? It's going to be 6 years. All right. Again, feel free to pause the video at any point if you've got questions. You can always ask me as well, or you can continue watching the video and go back and see what maybe you missed. All right, so let's look at example 2. Again, all the direction says is solve. I'm solving for that variable, which is x, and I've got this equation of 8x minus 6x minus 25 equals negative 35. Well, if I'm looking at this and remembering about simplifying my equations, I can only simplify or combine things that are like terms. In this case, I have an x and an x. Before I even start writing this out, I'm going to combine 8x and 6x. Notice, though, that there is an operation of a subtraction in the middle here. So really I'm taking 8x minus 6x, which ends up giving me 2x. Because I'm just taking those coefficients, I subtract those, keep the x. So now I have 2x minus 25 equals negative 35. Again, I like to draw the line down the center. I'm going to undo the addition or subtraction first. Then in this case we have subtraction. The opposite of a subtraction is addition. So we're going to add 25 to the other side. These cancel each other out. I'm left with 2x equals. And then thinking about my integer rules, I have a negative 35 plus a positive 25. So if I added those together, I end up getting a negative 10. Again, I'm okay if you want to use a calculator for this one, if you weren't 100% sure on that. And then I need to undo my multiplication, so I'm going to divide on each side. This is usually how I show division, is with that fraction part. 2 and 2 cancel, so you're left with x, because 2 divided by 2 is 1. And then negative 10 divided by 2 is a negative 5. Remember, a negative divided by a positive keeps it a negative sign. And that is my solution, or my solved problem for example 2. Okay, take it slowly, step by step. Think about why you're doing each operation so that you understand how to undo them and to get that x or that variable by itself. Alrighty, I know lots of examples as we're going through. I will have you do one problem at the end once we get through this. I love talking about algebra though, so I probably am going way too fast. Slow it down if you need to, or reverse back and you can continue watching it a couple of times. So this one, as I can tell right now, again, it's just, the directions are just solve. I want to solve for the variable of x. And in this case, I have something that I need to do first. In theory, looking at this, you could think, oh, maybe this is a PEMDAS operation. But I don't know what x is. And so what we're going to have to do is we're going to need to use the distributing property before I can do anything else to operate on this, basically. So I'm going to distribute the 2 to the 1. 2 times 1 is 2. Then I'm going to distribute the 2 to this 5x. And there's an operation of a subtraction in the middle, so that's going to stay. 2 times 5x, well, all that does is multiply that coefficient. So 2 times 5 is 10, and I still have the x. And then I still have this plus 4 on this side, and then I have an equal negative 8. I always suggest writing out your equations again. Don't just necessarily start with how they wrote it. Rewrite it out so that you can show out that work. I want to get x by itself first, but I've got a 2, I've got a 4, I've got a negative. So if I'm going to do this, let's actually combine this 2. Actually, can we do that? Combining the 2. I think we can. All right, so we're going to combine the 2 and the 4 because they're like terms. They're both constants. So I have a 2 plus a 4. Well, 2 plus a 4 is 6, so negative 10x. And we can move this back here, that's fine. Plus 6 equals negative 8. So again, it looks like we're always having something with a multiplication right now, and then an addition or subtraction. I'm going to get rid of this addition of 6, so we're going to minus 6 to each side. Put this negative 10x on this side. When I combine these, it's like saying negative 8 plus a negative 6, which gives me a negative 14. I'm going to undo this multiplication of negative 10 by dividing by negative 10 on each side. I'm left with the x on this side. If I grab my calculator and actually do negative 14 divided by negative 10, it's going to come out with a decimal. We're doing a division of a negative by a negative, so it cancels to be a positive. And I'm left with 1.4. And that's okay. We can have decimals, we can have fractions within our problems here with multi-steps. Alrighty, so let's keep going. Pause if you need to, ask me questions in class if you need to. I'm always there and available. So I think I have one more kind of example here. So use the table to find the number of x you need to run on Friday so that the mean number of miles run per day is 1.5. Oh, so we need to figure out, so this is actually going to be a mean problem, okay? Mean, or what else, or is another name for mean? It is average. Remember when you're finding the average, I think I spelled that right. When you're finding the average, you're adding up all those days and then dividing by, or adding up all those data values and then dividing by how many there are. So in this case, I'd have something like 2 plus 0 plus 1.5 plus 0 plus x. And then I want to divide it by how many days of the week? Well, there were 5 days here. This is the traditional work week. I'm dividing it by 5. And they want the actual mean number of miles run per day to end up equaling 1.5. So we're going to have it equal 1.5. Ooh, that looks like a really big problem, but don't be worried by it because we've got quite a few of the things that we can combine to fix this up and we can solve. So think about this. If I'm adding 0, we don't really even need to have these added zeros in there. So I'm actually going to combine all of this part because they are like terms on the top part of my fraction here. So I'm adding 2 plus 0 plus 1.5 plus 0. So in that case, I just have 3.5. I'm still going to have this plus x on the top. Divide by 5 equals 1.5. Now here's a problem where I would like to get rid of this division of 5 before anything else. I don't want to move over that x. I don't want to move over the 3.5. This is a problem where because the entire operation is being divided by 5, we need to get rid of that 5 first. And so to undo division, we multiply. We multiply each side by 5. That cancels out this part. So then you just have the 3.5 plus x equals, and we're going to take 1.5 times 5, which is 7.5. Now, the tricky part comes to be that I have a constant in front of the x. This constant, looking at 3.5, is positive. I don't have an operation in front of it, but it is a positive 3.5. In that case, to undo a positive or to move it over and so that it equals and cancels each other out, you have to think about its additive inverse, or the opposite of 3.5. The opposite of a positive 3.5 is a negative 3.5. So to move this over, I actually need to subtract this. I don't have a ton of room down here, but let's see if we can squeeze it in. These cancel out. I have 7.5 minus 3.5, and we'll just double check in the calculator, which gives me x equals 4. So means that on Friday you've got a lot to work on because you slacked off on other days, and so now you have to run 4 miles on Friday so that your average is going to be 1.5. And again, I can always plug this back in and see if that works. So if I took 2 plus 0 plus 1.5 plus 0 plus 4, that's 7.5. If I divide it by 5, do I get 1.5? And I do. So I know that my solution is correct. Alrighty, so I want you to just try and solve out this problem as your way of showing me that you are following along with this video. So the biggest thing is going to be that you add in or combine those like terms and then just solve for x and check your work, okay? Put in your answer on the sidebar over here and I will check in with you guys tomorrow and we will discuss more about this topic. Have a good rest of your day. Keep on working.